To solve this question, we're going to go ahead and try to find the value of this fraction. So we'll need to simplify and see what it's going to come out to. It should come out to an integer since those are the only answer choices that were given. So let's go ahead and start to break this down. There's a couple ways that we can do that. We could actually just multiply everything out following order of operations and then simplify. That actually wouldn't be the fastest way for us to finish this problem. Since we don't have a calculator, it's going to be a little bit difficult if we did want to multiply everything out. It'd be really time consuming. So instead, we're going to go ahead and try to use some exponent rules. We have exponent rules that say that if we have the same base, we can adjust the exponents in a certain way. So let's go ahead and try to break things apart, see if we can get the same bases to show up in the top and the bottom. Since we already have a nice kind of broken up terms in the top, we can go ahead and start to break apart 120 because we know that's a really large number. So let's start there, and then if we need to break apart this 6, because that's the only one that's not a prime factor right now, we can go ahead and do that. But let's go ahead and start with the 120 squared. So let's leave the top alone. The numerator alone, we'll have a 6 squared times 5 cubed times 2 to the 4th over, and let's think about how we can break apart 120 squared. Now ideally we're looking for bases that will match the ones on the top so we can start canceling things. So let's start with 6 and see if 120 we know is divisible by 6. It goes in 20 times. So we can actually break this apart. 120 is 6 times 20. Now 6 can be broken apart further, but we already have a base of 6 in the top. So let's leave it for now, and if we need to break it apart later, we can. But 20, we don't have a base of 20 in the top, so let's go ahead and continue to break that apart. We still have the numerator 6 squared times 5 cubed times 2 to the 4th over. We still have our 6. We're going to leave that alone for a second. And 20 we can break apart into 5 times 4. Or we don't have a base of 4 in the top, but 4 is 2 squared. So we can actually rewrite that as 2 squared right now if we want. So it's just breaking apart 20 into 5 times, this is really 4. And we still have this squared term outside of our parentheses, which we're going to have to deal with in a second. Now we can't start canceling in the numerator denominator until we follow our order of operations, so we're going to need to square each of these terms before we can actually start canceling away. So let's square each of those terms in the bottom. Again, we're leaving the top alone for a second. 6 squared times 5 cubed times 2 to the 4th, all over. Now squaring each of these terms, we're going to get a 6 squared times a 5 squared. And when we square 2 squared, when we have a power to a power, we multiply the exponent. So that'll be a 2 times 2. So 2 to the 4th. Now we can cancel anything that we have in common. If we kind of look at what we have in common in the numerator denominator, we have 6 squareds in common. We can actually cancel those out. We have a 2 to the 4th in common. Those match exactly. We can cancel those out. Now we also have 2 fives, so 5 squared in the bottom, that's 2 5s, and we have 3 5s in top. So if we cancel, we're subtracting exponents. So 5 squared actually cancels with 5 cubed, and we're left with 1 5 in the numerator. Now if we think about what this actually means, what this leaves us with, we have a 5 to the 1 in the top and nothing in the bottom, so technically there's a 1. If we cancel everything, it's going to be left with a 1 in the bottom. And that just gives us the whole number 5. That's an answer choice, so that's good. So let's go ahead and we would mark B, choice B, as our answer choice.